So with this example, this is actually part D of work example 30, but I wanted to do the whole thing using the CAS so you can see how quickly you can do this if you're in like a multiple choice situation. So first thing to do is look at the graph and the shape it's going to be. Now you know that Y here is first, so this is going to be one of those north-south type hyperbolae, which means we're going to look for Y-intercepts, and we also still need our centre and our asymptotes. So we're going to find, first of all, what our centre is. So we can read that off the graph. Be very careful here because the y is first and the x is second. So the x coordinate here would be -2 and the y would be 1. So the centre will be at -2, 1. To find the asymptotes, remember that what we do is we actually let this part of the equation equal 0. Okay, what I'm going to do in my CAS is I'm going to put this part of the equation into my CAS, and I'm going to show you something you can do with that that's really quick. So into my CAS, I'm going to type in a bracket. I'm going to do y take 1 all squared on 9 take away x plus 2 all squared on 4. Let's make sure that's right. Oh, it's the other way around. A good idea to check before you commit. So this is the left-hand side of your hyperbola. Now what I'm going to do is I'm actually going to store this left-hand side, and I'll press Control and then var, and what will happen is you'll get this little arrow, and that's using stow or store. I'm going to store this as left-hand side. I'm going to call this L. Okay, so I'll press Enter. So that's my left side of the equation. Okay, now I know that, for example, the hyperbola equation is the left-hand side equal to 1, and it's not been factorized, it's been expanded here. Okay, now to find the asymptotes, remember that we can just let the left-hand side of the equation equal 0. So what I'm going to do is actually let the left-hand side equal 0, so that's this equal to 0, but what I'm going to do is I'm going to solve that equation and solve it for y. So that will give us the asymptotes as y equals something. When I push that, you get your asymptotes, which is awesome. So you get them really quickly. Okay, so I'm just going to copy those over. So storing your left-hand side just makes some of this work a bit quicker. So there, your asymptotes done. The next thing that we're going to do is we're going to try and find intersects. Now we know here, because of the shape of this graph, intersects are going to be y-ints. So that's when x equals 0. So what we can do is actually look at the equation for the hyperbola, which is L equals 1. So left-hand side equals 1. And what we're going to do is a substitution. Now to do a substitution in here, we can use this symbol, which is a line. So basically Control equals will bring up this menu. We want this line here. It's the line that means such that. So you're saying L equals 1 such that x equals 0. So that's your substitution. Okay. Now what we can do is actually, once we've done the substitution, if we press equals, you can see here that you've got the y just on its own. So let's solve our answer. Control negative, so answer. Let's solve that answer for y. You could do that all in one step if you want. So just actually solve this for y up here. And you can see now, solving this equation, you've got your 2 y-intercepts. There's no x's in there because they're values. And if you wanted to as well, you could do Control equals or Control Enter, and that will give you the approximate values. So they're approximately -1.4 and 3.4. So you can see that symmetry again. So that's your intersections. Cool, so we've got everything that we need. So we could actually sketch this by hand if we wanted now, because we have enough information, but we're going to use the CAS to do that. So what we're going to do is just go into a graph page, and menu, graph, equation, so 2, hyperbola, which is 5, and we know it's a south-north because, or north-south, because it has y first. It's y take away 1 on, I did this backwards last time, what was it? On 4. Okay, so y take away 1 on 4. Oops, so let's do that again. So sometimes if you go back and you've put other graphs in, you just go menu, just get back the formula that you want. So I want the hyperbola, that one. So y take away 1 on 4, and it was x plus 2 on 9. Now remember, I've done a mistake that a lot of people here will do, which is to just straight up put your numbers in. Remember, it's not 4, it's the square root of 4. It's not 9, it's the square root of 9. And you'll know anyway as soon as you sketch it because it'll be really big. So now you've got your hyperbola. We can put that in. Cool, so that's our hyperbola. The nice thing is here, you can also, again, click on your graph menu, analyze graph, so 6, analyze conics, and you can find the center. It will actually tell you it's -2, 1, so that's what we thought it would be. Remember when we looked at it by hand? And to find out whether or not our asymptotes are correct, we can actually sketch them, because we found our asymptotes. They were these guys here when we let the left-hand side be equal to 0, so it's these two. So I'm actually going to sketch those in. So I'll just copy that, and we'll do a new graph, so tab, just push tab, and because this is in the wrong form, just go back to menu, graph entry, and change it to function. So graph entry 1, so 1, 1, menu 1, 1. And we'll put in the first graph, so you can see, check it out, that's totally the asymptote, because it goes through the center and it approaches our graph. And the other asymptote that we have was this one, so I'll just copy that again. And again, I'll just push tab and paste, and awesome. They cross at the center point of the hyperbola, and our hyperbola clearly approaches them but doesn't touch them. So these are definitely our two asymptotes. It's always just a great idea to check, just to make sure that you've done it correctly. So this is the formula for our hyperbola in its north-south form, and the equations for our two asymptotes, and hovering over the center, you can see there your center is at 1 and -2, 1. So you've got all the information just by using your CAS. So the reason I suppose I wanted to do this example on its own is just so you can see how powerful and how quick you can do these questions with a CAS. I mean, you really want to know how to do them by hand as well, but the reality is that in a multiple choice situation, you want to be able to do them quickly. So all of this you could do very quickly, and storing things, so storing like this part here as the left-hand side, so calling this part here L, really help then with finding all of our bits and pieces there, asymptotes and intersects. So using the CAS for hyperbola is a really great idea, just cuts down a lot of your computation.